By this point, we've now covered all the skills, techniques and knowledge we now need in order to be able to work effectively at any of the vectors material that should come up in the exam. What's going to happen in this video is I'm going to present you with 4 questions from previous past papers. I want you to pause the videos, have a think about the techniques, have a crack at the questions, and then check how you handle this level of material with the working I'm going to present to you. Here they are. There's your 4 questions. One's looking at perpendicular vectors, another one's looking at scalar product and angles between vectors. Number 3 is looking at dividing up in ratios, calculating coordinates, and then looking at a vector of certain magnitudes. And the 4th one is looking at pathways. It's presenting to you pathways of vectors and it wants you to calculate journeys. Now, key thing that you should know, questions 1, 2 and 3 all come from non-calculator papers. Question 4 comes from a calculator paper. Pause the video and have a crack. So the first one, I've got 2 vectors, v and u. They're perpendicular and I want to calculate the value of t, which is this missing element here in v. Now as soon as you see that, vectors and perpendicular, the first thing that should spring into your mind is the property a dot b equals 0. As soon as you're thinking about vectors which are perpendicular, this is probably going to be used in some way. We want to determine the value of t. Well, if we do u dot v, we're going to get some sort of scalar out of there, but it's going to have a t in it. It's going to be an equation, which we can then set equal to 0 and solve. So for this one, we want to do u dot v equals 0, and hopefully that'll allow us to solve it and figure out what the value of t is. So u dot v, work it through as we normally would. First element is 8 times negative 3. It's then plus 2 times t for the second element, then plus negative 1 times negative 6 for the third element. And again, to figure out what t is, we set it equal to 0. 8 times negative 3 is negative 24. 2 times t, so that's plus 2t. Then negative 1 times negative 6 plus 6, and that equals 0. So we've then got 2t minus 18 equals 0. This is an S1 standard equation you should be able to solve. You've taken a problem at a higher level, used a higher property, and broken it down to a problem which, if I presented this equation to you in S1, you should be able to solve. 2t is equal to 18, t is equal to 9. There you go, you've got the value of t that will allow you to figure out what the 2 perpendicular vectors are. Second question, if I've got u and v given by these 2 vectors respectively, first thing I have to calculate is u dot v. Then the second thing I'm told is that vector w makes an angle of pi over 3 with u and has this magnitude, calculate u dot w. First thing you should notice is they're both scalar products. One involves an angle, one involves a pair of vectors. So you're going to have to use both variations of it. You need to start to make sure that you understand these. So for example, if you've got a dot b and you know the 2 vectors, you know it's going to be a1 b1 plus a2 b2 plus a3 b3. But if angles come into play, you know you're going to have to work with one that's the magnitude of a, magnitude of b, cos theta. You need to make sure you know both of these different variations of the scalar product because they'll both come up, or they've both got the same opportunity to come up in the same odds. So for part A, I want to do u dot v and know all elements of both vectors. It's going to be the first variation I have to use. So start by doing it, first elements together, second and third, add them up and see what you get. So I get 5 times 3 plus 1 times negative 8 plus negative 1 times 6. 5 threes, that's 15. 1 times negative 8 is minus 8. Negative 1 times 6 is minus 6. So I get 15 minus 8 minus 6 gives me 1. So u dot v in this case is equal to 1. For part B, I'm given an angle between the 2 vectors and I'm told the magnitude of 1. So what this means is I need to think about the second version of the dot product. I need to think about the second version of this scalar product and use a dot b equals magnitude of a, magnitude of b, cos theta. But obviously use the variation we've got here. So in this case, it's going to be u dot w equals the magnitude of u, magnitude of w, cos theta, where theta is the angle between them. Now looking at this, I'm told w, the magnitude of w, and I'm told the angle. I have to calculate u, but I've got the vector here, so it should be a fairly straightforward calculation to do. The magnitude of u is given by the square root of 5 squared plus 1 squared plus negative 1 squared. So 5 squared is 25, 1 squared is 1, negative 1 squared is 1, so 25 plus 1 is 27. So it's the square root of 27. This can be simplified to 3 root 3. 27 is 9 times 3. 9 is a square number, so it's the square root of 9 times the square root of 3, which gives me 3 root 3. This kind of simplification will help you when it comes to doing calculations later on. So magnitude of u, magnitude of w, cos theta, I now know all three parts, I can plug them in. So 3 root 3 times root 3 times cos of pi over 3. Now pi by 3, that's the equivalent of 60 degrees. Cos of 60 degrees is equal to a half. So we can substitute that in and work it through. So I get 3 times root 3 times root 3. Root 3 times root 3 is just 3. 3 3s are 9. Then dividing by 2, so it's 9 over 2. There you go, there's your final answer for A dot B in this case, using that variation of the formula. Third question. I've got first part being A and C are these points here respectively. Point B divides AC in this ratio. Find the coordinates of B. Now this may not look like a vector, but it's a three-dimensional question. It's bringing in points. It's then allows us to take this part here and look at different vectors. So let's have a crack at both of these. For part A and C are the points here. B divides AC in the ratio of 1 to 2. Find the coordinates of B. Think back to when we did straight lines. I had 2 points. I've got A and I've got C, and there's my point B. Point B divides this line in the ratio of 1 to 2, so it's like that. So this is the one where we have to think of the formula where if I've got U and I've got W being the parts of my ratio, this means that B is equal to, and then you cross them over, W times A plus V times C over W plus the V. Calculate all this and we should be able to work it out. So B in this case is going to be W times A. Now W is the opposite side, so it's 2. So it's going to be 2 times the 1, 3, negative 2, plus 1 times the 4, negative 3, 4. So what the C coordinate is. And then that's all going to be over the W plus V, which is 3. So in this case, it's going to be equal to a third, and then we just calculate all the bits. So 2 times 1 plus 4 is 6. 2 times 3 is 6. Plus negative 3 is just 3. And then 2 negative 2's are negative 4. Plus 4 gives me 0. So it's 1/3 of 630, so I know that B is then going to equal the coordinate 2, 1, 0. So there you go, I've got the coordinate of B. What I now need to do is take the vector part here. So KAC is a vector of magnitude 1. K is bigger than 0. Determine the value of K. First thing I need to do is get the vector AC. Now remember, AC is when you take C minus A, where C and A represent the position vectors of the coordinates with respect to the origin. But the cheeky way of doing it, take the coordinate and list it as a column vector. So in this case, it's going to be 4, negative 3, 4. Take away the A, which is 1, 3, negative 2. So what that means is my vector A to C is 4 minus 1, which is 3. Negative 3 minus 3, which is negative 6. And 4 minus minus 2, minus minus becomes a plus. 4 plus 2 is 6. So I've got that there. Now, KAC is a vector of magnitude 1, where K is bigger than 0. Determine the value of K. So K times AC is a vector of magnitude 1. So what that means is if I do K times the magnitude of AC, I'm going to get 1. We could take K out as a factor, and that'll work that way as well. So First we calculate the magnitude of AC, substitute it in and see what we get. So the magnitude of AC equals the square root of 3 squared plus negative 6 squared plus 6 squared. So 3 squared is 9, so it's the square root of 9. 6 sixes are 36, so it's plus 2 of those. So 36 plus 36 is 72, plus 9 is 81, so it's the square root of 81, which is just 9. So the magnitude of AC is 9. What that means is 9k equals 1. Solve that for k and you get k is a 9th. So there you go. For it to be a vector of magnitude 1, k has to equal 1 over 9. Final question was a diagram like this. It shows a triangular prism. It's got a few vectors marked on it. So AB is equal to the vector t, AC is equal to u, and AD is equal to v. We have to express a couple of journeys in terms of these. So the first one it wants us to do is express B to C in terms of u and t. Now what you have to do is determine how the journey goes. Now B to C, you can go straight from it. Perfect. The only issue is we don't know what that vector is. So we have to determine a journey that we can go on that follows some of the vectors we already know. We have to be able to do it. So we have to start at B and figure it out. Now if we go from B to A, then A to C, we make our journey and we're able to get the vectors we want. So we know that B to C equals B to A plus the A to C part of the journey. Figure out the journey you're going to go and write it down. Then you figure it out in terms of the variables at once. B to A, well A to B is t, so B to A going back the way is negative t. And then A to C going along is u, so it's u. So the final answer is negative t plus u. If you wrote it as u take away t, you'd be perfectly fine as well. There you go, there's your answer to the first one. Second one, M is the midpoint of BC. Express M to D in terms of t, u, and v. So I want to go from here to here. So I want to go from M to D in this case. Now the easy way to do it again is look at the journey we can take. If I start at M, I can go from M to C, C to A, then A to D. So I could do that one. So I've got the journey MC plus the journey C to A plus the journey A to D. All I need to do is figure out what each of these is in terms of the other parts of the journey. Now C to A is easy. It's just back along this one. That's minus u. A to D as well is easy. It's along the V, so it's plus the V. M to C is the interesting one. Now M we're told is the midpoint of B to C. I want to go from M to C, so I need to figure that out. Well, B to C is given by this part here. So if I want to go from M to C, I'm only going half the journey. So what that means is M to C is equal to a half of the B to C journey. So in that case, it's equal to a half bracket u minus t, take away u plus v. So I've got all the parts in, it's just a case now of simplifying. So I've got a half u minus a half t minus u plus v. Put all the bits together, you get minus a half t. A half u minus u gives you minus a half u, then plus v. There you go, I've got my journey there from M all the way to D following this route. Working in past paper questions, these are the skills that have to come naturally to us. We need to remember all the properties of vectors, we need to remember how to calculate vector journeys, we need to remember how to do scalar products, whether it's scalar products with all the elements or scalar products with angles and magnitudes. We have to be able to represent journeys in terms of vectors that it's given us and follow pathways. You have to be able to do all of this. These key skills should all be second nature to you by the time it comes to sitting this exam. Use these videos, use this information, make sure that's the case. Good luck.